Hello everyone. Today we are doing matrices, O levels maths 4024 syllabus T topic, Cambridge system. Uh, Before starting matrices, we should know this. What do you mean by matrices and how we can represent a matrix? Normally, this like when we have a bracket, and the bracket can be a square bracket or it can be a bracket like here. This can be like this, and we have some numbers in this like 5, 3, -2, 6, A, B, C and D, and we write with equals to an alphabet with capital letters, suppose A, and suppose here M. It can be like if I write here a matrix B with this bracket and 5 and 2, and one more example I would like to write like C equals to 6, 3, and one more example D equals to only 5. Like there are number of ways to represent uh, uh, this matrices. In matrices, normally the numbers here, we are having 4 numbers in first matrix. That is called the members of the matrices or the elements of the matrices. There are 4 members, there are 2 members, there are 2 members, and there is only 1 member for the element. Okay. In matrices, what we should know that these vertical, the vertical line, the vertical members are called the columns, and the horizontal like here called the rows, right? So it means when we observe here how many columns are there and how many rows are there. So there are 2 rows and 2 columns. Here we can also see the number of rows are 2 and the columns are 2. And when we observe this B, this 1 column and there are 2 rows, so what we can write, this R is 2 and the column is 1. Here R is just 1, okay, 1, and the columns, there are 2 columns here, 2, and here 1 row and 1 column. So basically when we have this type of system like this bracket and the numbers, this is called the matrix with an equal sign in alphabet, capital letters. And what is very important here, this we should write here the order of matrix. Order of matrix. How we can find the order of matrix is very simple. The order of matrix is equals to row multiplied by column. Okay, when we see this, what is the order of this matrix? Can you write? The order of matrix A is 2 by 2 because 2 rows and 2 columns. The matrix M, 2 by 2, we write 2 by 2, don't multiply 2 by 2 is 4, just write 2 by 2. 2 rows, 1 column, so we write this matrix B order has 2 by 1. This is 1 row, so 1 by 2, 2 columns, and this is 1 by 1. So the first important thing in matrices, we should know the order of the matrix, okay? Second thing, just as we are giving the complete explanation about this topic, so we should know the types of matrices. There are so many types of matrices, but I would like to give like some examples here by using this 5 matrices. When you observe when the number of rows and columns are equal, this is called a square matrix. Even you can see what is becoming. It's becoming a square. Yeah, that's why the square matrix. This is a square matrix. Like I'm writing here, a square matrix is one type. Okay, then we have a rectangular matrix. Rectangular matrix means, what do you mean by rectangle? This is a rectangle. Yeah, 2 lines small and 2 big. So this is a rectangular matrix. This is a rectangular matrix. This matrix is a square matrix. It means in a square matrix the number of rows and columns are equal, but in rectangular matrix the number of rows and columns are not equal. Like the basic types of matrix. Then we have diagonal matrices, and there are so many types of matrices, but according to our O levels 4024 Cambridge system, we should know only these matrices. Then we have zero matrix, and I will discuss later. Okay, after this I would like to move further here. I have already given an example of matrix 2 by 2. Okay. After this, like order and types of matrices, we should know this how we can do the addition of the matrices, like addition, subtraction. Addition and subtraction, we can say this is both go together. We can say, like, for addition and subtraction, what are the rules that, like, when we have the same example here, matrix A and matrix M, when you observe this, when the order of two matrices are same, we can add or subtract. Like, there are 4 members and 4 members order are same, so we can do the addition and subtraction. Like B and C, we cannot do the addition. A and C, we cannot do the addition, and B and D, we cannot do the addition. So we can do the addition only when we have same number of like order same, then we can do the addition or subtraction. Okay, for example, when I want, like, I have A matrix is 1 2 3 4, matrix B is -2 3 4 2, and I want to add it. So it's very simple. When I want to add it, so A plus B, I can use this bracket also, 1 2 3 4, plus sign in the middle, then I can write -2 3 4 and 2, and then we can do the addition. That's coming 1 plus, like, plus minus is minus, so it's coming -1. 3 plus 4 is coming 7. 2 plus 3 is coming 5, and 4 plus 2 is coming 6. That is called the addition. When I want to do the subtraction, A minus B or B minus A, we have to careful. This A required first to write here, because A minus B is required, and -2 3 4 is very general law, like how we do the addition or subtraction. First member with first member, minus is plus, so 1 plus 2 is 3. 3 minus 4 is 1 is -1. 2 minus 3 is -1. 4 minus 2 is 2, and that's A minus B. This is very simple method. Okay, I would like to also add here, like, when I multiply a number, multiplication a matrix by a number, because I am not doing the multiplication of the matrices, multiplication a matrix by a number. Like, I have a number and I want to multiply with a number, like, okay, so it's very simple. I'm giving one example here. Like, if this is our question, I want to find, suppose, find 2A. So 2A means A is here 1 2 3 and 4. This multiplication by a number, that's this number will multiply with each and every number. We can do it 2 by 1. So the 2A is coming, 2 by 1 is 2, 2 is a 4, 2 3 is a 6, and 2 4 is a 8. That's your result. And by same method, we can do the calculation, like sometime in the exam we have 2A minus 3B. So it means you have to multiply 2 with A, then 3 with B, and whatever the results are coming, you can do the subtraction. That's very simple. Addition, subtraction, and multiplication are matrix by a number. That's very simple topic here. Okay, next most important is multiplication. This multiplication is not easy actually, but this is a little bit difficult as addition. So matrix multiplication, this topic I would like to just give attention here. Matrix multiplication. In matrix multiplication, okay, Do not forget the order. Order is very important because without order, when you don't know the order of a matrix, you cannot work for the matrix multiplication, and that is also used in transformation. Okay, matrix multiplication is what? Like when there is a condition, I'm writing here. The condition is what? The condition of multiplication is fixed. The column of first matrix should equals to the number of rows of second matrix. Like this condition is very important, and without this condition we cannot work like for the multiplication, and when this condition is not there, it means multiplication is not possible. For example, I would like to give one example first. Like A is 2, 3, 4, 6, and B is 2, 1, 1, 3, and I'm writing also C. C is row column, so I can write 3 and 6 only. Okay. Okay, when I want to multiply A with B, like this A multiplication, first of all I should know the column of A should be equals to the number of rows with B. Do we have equal? How many columns are there in matrix A? There are 2 columns, yeah? And how many rows are there in B? There are 2 rows. Okay, it means multiplication is possible. And how we do the multiplication I will discuss, but before that we should know the condition of the matrix multiplication. For example, we have A and C. I just want to check it out. This multiplication is possible. Like I have to write here A and then B, and I have to do multiplication. Okay. Okay, A and C. How many columns are the columns of the first matrix should equal to the rows of second matrix? This is very important. So column is what? Column, number of columns in A are 2, and number of rows in C are 2, and multiplication is possible, like 2, 3, 4, 6, and this is 3, 6. Multiplication is possible because we do not multiply with first number with first and second with second. No, there is actually a method to do the multiplication for matrices. So what is the method actually? This condition is very important. We cannot leave this condition. We have to always remember this. Without this condition we cannot multiply. Okay, now next target is what? What's the method to do the multiplication? Okay, condition we know. So method is what? The method is very simple, but you have to remember, like let's suppose the matrix A is, I am writing a formula for this: A, B, C and D, and matrix B is like A and B, and matrix B is P, Q, R, S, and I want to do the multiplication. This is a formula. I am just writing a formula of this we can do. Okay. Condition is what? Column of the first matrix should be equals to the rows, number of rows for the second matrix, and this apply here, and multiplication is possible. But how we multiply? For multiplication, what is the formula to find the order? Row multiplied by column. So we do the same thing here. We multiply rows with column. The first row multiply with the first column. First I have to complete all the columns with the first row, like A multiplied by P plus first row and first column, like complete first column I have to multiply, but first member with first, C with Q. So this is the first multiply, first row, first column. Do we have second column? Yes, second column. Again A and C with R and S, but with the space here. A multiplied by R, A multiplied by R plus C multiplied by S. Like when we have one more column or other columns, we have to do the same thing by making space and multiplication with the number rows with columns. Okay, like first row, first column, first row, second column. Do we have any other column? No. That's it. Now moving to the second part, like here. The second part, what we have to do? Second row, first column. Okay, second row, first column. What we have to do? We have to do the same thing. Like B with P plus D with Q. Second row, first column, space, second row, second column, B with R and D with S. And do we have any other column? No. And that's it. That's your multiplication. And you can do the multiplication. Yes, that's the formula. When I move to up, this I have given one example here. When I do the calculation here, okay, let's see. When I want to do the calculation here, okay, what are the calculation? The calculation are here is 2, 3, 4, 6, and the B is 2, 1, 1, 3. Okay, so I'm doing the calculation here. What's the method? What we do? First row, first column, then first row, second column. So we have to do it. 2 multiplied by 2 is 4 with plus sign. 2 multiplied by 1 is, 4 multiplied by 1 is 4. 2 4 multiplied by 2 1, and that's 2 4 multiplied by 1 3 with the space. 2 by 1 is 2 plus 4 by 3 is 12. Do we have any other column? No, we have to close the bracket. Okay, moving to next part. 3, second row with first column and second column. 3 multiplied by 2 is 6 plus 6 multiplied by 1 is 6. 3 multiplied by 3 is 9 plus 6 multiplied by 3 is 18. And by this way we can do the addition, and then we can do what's the result here now. 4 and 4 8, 12. This is 14, and that's your result 27. Okay, and we have done it. For example, here the number of column, the column of the first matrix, there are 2 columns and 2 rows, so we have to do multiplication and we can multiply. So what's the method? First row, first column, first row with first column. I have to do it first. 2 multiplied by 3 is 6 plus 4 multiplied by 6, 24. 3 multiplied by 3 is, okay, first row, first column done. Do we have any other column? No. Then we have to move to the second row. Now 3 multiplied by 3 is 9 and 6 by 6 is 36. So what's the final answer? The final answer of AC is 24 and 6 we can write 30, and 36 and 9 we can write 45, and that's your answer. Like this is the way we can do the multiplication and so on. After multiplication, the most important thing is the most important thing here is inverse multiplication. But before inverse multiplication, I would like to discuss about the singular matrix and what are the determinants. I think so I should go together with inverse matrices and determinant. Yes, inverse matrix. Okay, after this explanation, I am going to do the possible questions. Inverse matrix, basically we write like here, when we have a matrix with power -1, that's inverse, and there is a formula for finding the inverse matrix. The formula is to find the inverse is A inverse is equals to 1 upon determinant A multiplied by adjoint A. Okay, this is the formula. Okay, I would like to do 2 things together. One example, like example I'm writing here, a formula and example. The method is what? The method, and I'm also writing one example here. This is how we can work on it. We have number of questions from the past syllabus we are doing, but before that I would like to give one example. A is A, B, C and D. Okay, this is one like example method to use for making a formula. An example we can take here 1, 3, 2 and here I think so if I take 4 is better. Okay, that's better 4, and this I can take minus 2. Minus 2 is better to take here because I have to use sometimes the change of sign, and is minus 4 here. Okay, now this is one example here. What's the method actually? The method is what? First we always find the determinant. Finding determinant is very important. Why we find the determinant? Because determinant decide this inverse is possible or not. Like when the determinant is here, I'm writing when the determinant of any of the matrix is equals to 0, that's called a singular matrix, and I want to use this word. Singular matrix means when the determinant is 0, and this is very important. I want to use this is because we have seen in like paper 1 past paper questions. Determinant is what was the method of determinant? Just when we write this like this, A, B, C and D, what's the determinant formula? What we do, A multiplied by D minus B multiplied by C. This is a formula. Okay, when you want to find determinant here, what's the determinant of A here now? The determinant of A is 1 multiplied by minus 4. Yes, minus of the formula. Singular matrix, don't forget it, but I will also discuss about singular matrix. Minus 2 multiplied by 3. Okay, let's see what's the determinant. Minus 4 minus minus is plus, 2 3 is 6, and that's coming 2. When determinant is not equal to 0, inverse is possible. So the inverse is possible because this is not a singular matrix. Okay, then I am moving to here adjoint A. How we can find adjoint of A is very simple, and the formula is when you want to find adjoint of any of the matrix, what you have to do? You have to use this method. This direction you have to sign change sign, and this direction you have to change its place, like sign change and place change. So what is the adjoint of this part? Adjoint A is this, what we do, sign change. Sign change means minus 2 will become plus 2 and 3 will become minus 3. This is what sign change here. Now here the place change, the position change. Position is what? 1 and minus 4. And this will become minus 4 and this will become 1. This is your adjoint A. Now when we have these two things with us, like determinant and the adjoint, then just we need to put the value in the formula. That's 1 upon determinant. Determinant is 2 multiplied by, and adjoint A is this minus 4, 2, minus 3 and 1. When you simplify, or even I have seen in the examination report, this student can write the answer like this, but my advice to you, just please expand. Like here you can write A inverse is 1 upon 2 multiplied by minus 1, minus 4 is, you can write minus 2 only. This multiplied by this is minus 3 upon 2. This you can write just 1 half multiplied, this is 1 upon 2. But this is also accepted, and this is also. This is the inverse of a matrix. Okay, now we are starting the past paper questions. The past paper questions are from the first question, I think so we should start from here. Yeah. This is question from past papers June 11 paper 2 and question number 8a. The requirement in this question is this matrix A and B are given. The first, okay, I would like to solve it little fast, is 2a minus b. Okay, 2 with bracket a is 4 minus 1, 3 and 1 minus b. Minus b, I am writing here, the b is 5 minus 3 and 4 and minus 2. What we have to do, number multiplied by the bracket and divide the same. 2 by 4 is 8, minus 2, 6 and 2. Then we need to minus now. Then what we are having, 8 minus 5 is 3, 6 minus 4 is 2, minus 2 and minus minus plus 3 is becoming 1, and 2 minus 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 is plus 2, so it's coming 4, and that's your result. Okay, second part we are doing B inverse. Okay, for B inverse the formula is B inverse equals to 1 upon determinant of B multiplied by adjoint B. So that's the formula. First we need to find determinant. What's determinant? Because when the determinant is 0, means singular matrix, we cannot move further, we cannot find inverse matrix. Okay, so the B is 5 minus 3, 4 and minus 2, and we need to multiply like I have already explained in explanation this how we can do this. Okay, it's coming minus 10 and minus minus is plus 12, and the answer is coming 2. So the determinant is coming 2. And what's the formula to find the adjoint? Sign change here, and we do position change or the place change. So what I'm doing, I'm writing direct here, like B inverse 1 upon determinant is 2, and adjoint is sign change. Sign change, minus 3 will become plus 3, sign change, and 4 will become minus 4, and this 5 minus 2 position change, and you can write the answer. This is accepted, you can do it. Okay, question number, this is from past paper November 8 paper 1 question number 15. We can start here now. Okay, this is multiplication of matrix. First part, we need to find multiplication A multiplied by B. Okay, before multiplication, please do not do like the first member of the first matrix multiply with the first member of the second matrix. Please do not do like this, because this is only apply in addition. In addition, we can add the first with first, second with second, but in multiplication we have to like remember what's the condition of multiplication. Condition is the number of columns of first, I'm writing in short now, and the rows of second matrix. So how many columns are there in the first matrix? There are 2 columns and there are 2 rows, so we can, there is a possibility of multiplication, and the method is what? First row, first column, first row, first column, then first row and second column. We have to multiply with both. Okay, 2 by 4 is coming 8. Then formula normally we write plus, but minus, and like here, so minus 1. 2 times 3 is minus 3, minus 6, and minus 1 times 0 is 0. Bracket close. First row, first column, first row, second column. Now second row, first column and second column, we have to multiply. 1 by 4 is 4, then plus 3, 1 by minus 3 is minus 3, and 3 by 0 is 0. So your result is 7, minus 6 and minus 3, and that's your result. Okay, what about B inverse? We have already done in the last question, so I think so just try yourself. Okay, I have selected some like very important question that will definitely help you like in examination, like we have normally have in paper 1, this internal examination of CAIE, November 2003. This question, like A minus B, I think so you can do the subtraction, like A minus B, I am writing the direct answer, okay? A minus B means A and B. 4 minus 3 is 1, 3 minus 1 is 2, minus 1 and minus 4 is minus 5, and 0 minus 3, we have no 4 minus 3 is 1, 3 minus, okay, minus 1 and minus 4, this minus 4 will become plus 4, that's why sorry it's coming 3, minus 1 and minus will become, this is coming like only 3, because 0 minus minus is plus and the 3, okay, that's the result. B part, okay, this question, this is very important question, please be careful, and I would like to say this, please do not do the mistake here, because it's given A square. What do you mean by A square? Normally I have seen in examination report, like students have written like 4 minus 1, 3 and 0, and they are making the square, means each number is a square, 16, 1, 9 and 0, and that's no, this is wrong. This is wrong. Please do not do like this. This is wrong. So I would like to solve it again. This A square means I have to write what? A multiplied by A. So this we need to multiply with 4 minus 1, 3, 0, and 4 minus 1, 3, 0, and we need to do the multiplication, first row first column, first row second column, and so on. Okay, part C. Part C, the marks are not written here. This is 1 mark question. Like 1 mark question, how can you get the answer? So for this purpose, I would like to write here, this you should do the note here, that A multiply by A inverse. What do you mean by A inverse? 1 upon A cancel, the result is always 1. So it means 1. So it means, just to remember, when you multiply A with its inverse, like B multiplied by B inverse, the answer is 1. Like C multiplied by C inverse, the answer is 1. So please keep in your mind, okay? So like in C part, when you have A with A inverse to multiply and then 5 and 6, please, one thing, the effect of this part is 1. This is 1. 1 multiplied by 5, 6. What's the answer? Again 5, 6? And that's your answer. Please be careful. This was an important part, that's why I've taken these two parts, like you should know. Part D is C and D. Okay, C is 2, 3 and 4, and D is 3, 1 and minus 1. This is very important question. How many columns? Column of first matrix should equal to rows of second matrix. How many columns? There are 3 columns. Okay, I would like to write here one more thing here, like when you multiply, you should remember the condition of multiplication, but what will be your result? Okay, what is the order of this matrix? The order of this matrix is 1 multiplied by, how many rows are there? Column are there? 3. Okay, I am writing here, is equals to, the column of first matrix should be equals to the rows of second matrix. How many rows are there? 3. Okay, I am writing here 3 multiply, and how many columns are there? 1. So it means when these two things are equal, the multiplication is possible, okay, but your result, when you multiply, your result will have the order 1 by 1. Like this is a result order. So I want to check it now. How we can check? We can do the multiplication here, like here. Okay, what's here the multiplication? First row, first column, 2 multiplied by 3 is plus 3 multiplied by 1 plus 4 multiplied by minus 1. Do we have any other column? No. Then we have to close the bracket, and we require nothing. 6 plus 3 minus 4. You can see the result of the matrix order is 1. 6, 3 is 9, 9 minus 4 is 5, and that's the result, and the order is 1 by 1, and we have done it. Okay. This situation again, I have selected very old questions because of this, for the good practice. Given that A and B are given, find A minus B inverse of matrix. I think so. There is no problem. You can do it. These two parts. Okay. Again. Please be careful. B multiplied by B inverse is what? 1. And when you multiply with 5, 6, 7, 8, your result will be again what? 5, 6, 7, 8, and that's your answer. Okay. I think so. I should move to the next part. Okay. That condition we can apply here. This question, there are many possibilities, but I have 2 possibilities with me here. The inverse of this matrix is this. Okay. It means if this is A, this is A inverse. Okay. And I want to write a note here. A multiplied by A inverse is what? 1, and 1 actually we can write here also the I, and I is called the unit matrix. Unit means 1, and unit matrix is 1. And what's the unit matrix? Unit matrix is equals to what? 1, 0, 0, 1. So we can do the further here, like we are not writing 1 here. 1 and unit matrix are equal, but the determinant of this unit matrix is 1. That's why it's equal to the value, the magnitude of this result. Unit identity matrix is 1. Okay, find the value of x and y. What is the condition here? There are 2 possibilities. That sometimes what the students do, the students find the inverse of this part and with comparison with this part. What's the method actually? What students do? They find the inverse of this part. Yeah, first inverse of this question, and then compare with this. But I will advise this. What you can do, you can write the condition that A multiplied by A inverse is always equals to identity matrix. Very simple. What is A? X minus 1, 2, 0. A inverse is 0 minus 1, y into, and what is equals to identity matrix? 1, 0, 0, 1. Now it's very simple. That will be a long calculation to find the inverse of this part first and do the comparison with this. That's the long part. Okay. Multiplication. First row, first column. X by 0 is 0. 1 by 1 is minus is plus 1. First row, second column. X multiplied by y is xy with a space here. Minus 1 by 2 is minus 2. 2 by 0 is 0. Then 0 by minus 1 is also 0. Second row, first column, second row and second column. 2 by y is 2y. And 0 by 2 is 0 equals to 1, 0, 0, 1. Comparison. You can also simplify. This is coming what? 1, 0, x, y minus 2, and this is 2y only. So by this way, you can do the comparison or maybe apply the simultaneous equation method. Here. Okay. 1, 0, 1, 0 is it. X minus y, xy minus 2 is equal to 0. And 2y is equals to 1, so I am writing 2y equals to 1 first. So y equals to 1 upon 2. This is the first answer. Second part is what here? I am comparing this part with 0. So xy minus 2 is equals to 0. Y is 1 upon 2. X upon 2 is equals to 2. This 2 multiply x equals 2 and 4, and that's your result, and we have done it. Like I have selected some important questions. Maybe that will help you. Like this question, I have found this, we are having so many times question here in our paper. Okay, was the question this matrix y satisfy the equation? Okay, 4y minus 2 matrix is equals to y. Find y expressing in the form of this. Like you have to make y the subject here. Like 4y and this y. You can shift this y here. 4y minus y is equals to this. You can shift on right hand side 2 with 12 minus 9, 6 and 0. This is coming 3y. You can do the multiplication, there is no problem, but 3 will be coming here, so okay, I think so I should because 3 will cancel all the numbers. Okay, there's no problem, we can multiply. 2 by 12 is 24, then minus 18, 2 times 6 is 12 and 0. This 3 will divide in right hand side, so divide by each and every number. Like you can do 1 upon 3 and 24 minus 18, 12 and 0, and you can do the answer. Y is equals to 8 minus 6, then we have minus this 4 and 0, and that's it. Okay, then we have next part. Okay, this question please very important, the A part. This is November 4 paper 1 question number 1. The determinant of the matrix is 14. Please, I would like to write one more question here. Determinant means this sign, k minus 1, 5, 2. The determinant is coming what? 14. Find k. And what the determinant formula we multiply like this: k multiplied by 2 minus of the formula 5 multiplied by minus 1 and is equals to 14. So it's coming 2k minus minus is plus 5 is equals to 14. 2k is equals to 14 minus 5, that's coming 9. Then 9 upon 2 is coming 4.5, you can write, okay? Or you can write the answer in whole numbers 4 whole 1 upon 2. But one thing, before, okay, b is find the inverse of this and there is no problem, you can find the inverse of b part. But I would like to write the c part here, please be careful. Same question I'm writing that k minus 1, 5, 2 is a singular matrix. One example, I'm just giving one example. Singular matrix, find k. Find k. What do you mean by this? Singular matrix, determinant is 14 here in the given question, but there is no determinant here. Whenever you have a singular matrix, the determinant is always 1. Sorry, 0. The determinant is always 0 when we have singular matrix, means inverse is not possible. So what I will write? K minus 1, 5, 2. The determinant is 0. 2k minus is what? Plus 5, because minus of the formula, and k is minus 5 upon 2, and that's your answer. This is, I extend the question, this we can have a question in exam, this what do you mean by singular matrix. Then moving to the next part. This is the last question, internal examination of CAIE 2000 paper 1 question number 18. Maybe that will be a different question. Let's see. M is this, given that the determinant of M is y, the same condition, the determinant of this matrix is 4, 5, y, 3 is y. So we are having the question like this is what, 12 minus 5y is equals to y. This is coming what, 12 is equals to 6y, and y is equals to 2, and we have done it. B part, M inverse, this is M inverse, okay. Part 2 is A inverse, like M inverse. Determinant is already, the value y is 2, then you can just write 1 upon 2, and the determinant is what? Y is 2, so your sign change, the place changes 3 and 4, and that's your answer. We have done it. We have B part, okay, please once again M multiplied by M inverse, or M inverse multiplied by M is same. So that's result is 1, the identity matrix, and 1 multiplied by 1 minus 2 is 1 minus 2, and that's it, your answer. I have selected some questions from the past papers, and my request to you, this when you think this my video is beneficial and useful for you, please share with your friends, and please press the bell icon so that you can receive my new videos. Thank you so much, and ask for your friends to subscribe. Thank you so much. Have a nice day.